So my name is Reagan, and today I will be showing you experiment 16, Le Chatelier's principle. Many reactions essentially go to completion. That is, you start with some reactants, and as they react, they end up as complete products. So Le Chatelier's principle explains how the amount of products and reactants can change as a result of external stimulus, such as heat, pressure, changes in concentration, or changes in volume. For instance, adding reactants will push the reaction towards the product side. Adding products may push the reactants back towards the reactant side. So nearly every chemical reaction consumes energy or releases heat. Chemical reactions that consume energy are called endothermic. These reactions, if you felt them in a beaker, for instance, they would feel cold because they're pulling heat into the reaction. Reactions that release heat are called exothermic, such as a fire, for example. These reactions release heat, and they feel warm. If you add heat to an exothermic reaction, it will actually push the reaction towards the reactant side. And vice versa, if you add heat to an endothermic reaction, you'll actually push the reaction towards the product side because it will consume heat, and the more heat it consumes, the more products will be formed. Le Chatelier's principle also describes how a state of equilibrium, where the amount of forward reactants creating products is balanced by the amount of products that are becoming reactants. So as a reminder for safety, we want to make sure that we're wearing our goggles, we're wearing our gloves. We have a lab coat that's completely buttoned up. No skin is uncovered from the waist down. That includes long pants and closed-toed shoes, and that your hair is tied back if you have long hair. So today we'll be performing 3 experiments from your lab book. Experiment 1A, Experiment 2A, and Experiment 3A. For Experiment 1A, we'll be talking about the common ion effect using the chromate ion. And so for this experiment, you'll need 6 molar sodium hydroxide, 1 molar potassium chromate, and 3 molar sulfuric acid, and 1 test tube. So this is a test tube that contains 3 milliliters of 1 molar potassium chromate. So first, you'll need to make sure that you fill up this test tube with the yellow solution, which is potassium chromate, to the correct level. And then next, we're going to be adding sulfuric acid, and this color will turn from yellow to orange. So we'll add a couple of drops of sulfuric acid to the chromate solution. This will form the dichromate ion, which is orange in color. And as you mix it, you'll see that almost all of the ions will move towards the product side. You may have to add more acid to fully consume the yellow color in the solution. So now that the solution has become fully the dichromate ions, it is now orange in color. To reverse the reaction, we can add sodium hydroxide, which will return the solution to the chromate ion and will be yellow in color, like so. So now that it's back to being yellow in color, you can see that we have the chromate ion completely. So we've now gone back to the reactants like in the original solution. You can continue to go back and forth until it's too concentrated to see the color changes easily. So for this experiment, experiment 2A, we're going to be talking about the complex ion effects on equilibrium. For this experiment, we'll be using a 0.1 molar solution of iron nitrate, a 0.1 molar solution of potassium thiocyanate, and a 6 molar solution of sodium hydroxide. To begin, we're going to create a solution in a 50 milliliter beaker that we'll be using to fill these test tubes to show the color changes as we add different reactants or products and change the equilibrium. So to begin, we're going to add 3 milliliters of the 1 molar solution So we'll add that 3 milliliters of the iron nitrate solution to the beaker. Again, we'll measure out 3 milliliters of the 0.1 molar potassium thiocyanate solution into a graduated cylinder. We can then add this to the beaker and you'll see a color change. The iron thiocyanate complex is this deep blood red in color. So in order for us to see the color changes from the changes in equilibrium, we're going to add 50 to 60 milliliters of water to make this a little less dark. Until we get about a color that looks about like this. And then after we have made this solution and added the water, we will split up the solution into 4 test tubes individually. You can either use a graduated cylinder, or if your test tubes have gradations like these do, you can add 5 milliliters of solution to each. So now we're going to add some reactants to these mixtures here, and we'll see what the color changes look like as we do so. So first we're going to add 1 milliliter of iron nitrate to the first test tube. We'll add 1 milliliter with the dropper is about 25 drops, or you can use the gradations on the test tube or a graduated cylinder. Cap that and shake it up a little bit just to disperse it. And then to the second test tube, we're going to be adding 1 milliliter of the potassium thiocyanate solution. To the third test tube that we have here, we're going to be adding 6 drops of 6 molar sodium hydroxide. The sodium hydroxide will react with the iron thiocyanate ion and will actually complex the iron and remove it from solution. Iron hydroxide is mostly insoluble in water, and so we would expect a precipitate to form at the bottom over time. In the last test tube, we will leave alone so that we can compare the colors of these 4 test tubes. As you can see, the one that we added the iron nitrate to is similar in color, but a little bit darker pink. The iron or the potassium thiocyanate is now a deeper red color. And the test tube we added sodium hydroxide to is now yellow. So the last experiment that we're going to be doing is experiment 3A, the equilibrium constants and the equilibria of saturated solutions. So in this test tube, we have 4 milliliters of saturated sodium chloride solution, basically a salt solution. So to the 4 milliliters of sodium chloride solution, we're going to add 2 milliliters of 12 molar hydrochloric acid. If you watch closely as you add the hydrochloric acid, you will notice the salt crystals start to precipitate out of solution. So in just a short while, you'll notice that the sodium chloride crystals that precipitated in solution are now falling towards the bottom and forming precipitate in the bottom of the test tube. If you have any questions, please refer them to your TA and they will be happy to help.